Section 7.4, Example 2, on page 459, we have one way to measure the size of an angle is in degrees. To indicate the measure of an angle, write a lowercase m in front of the angle symbol. In the diagram, the measure of angle A is 62. You write this as measure with a lowercase m, angle A equals 62. In this book, you will only work with degree measures. So here we had 62 degrees for the interior angle measure. On page 460, we have a circle is the set of all points in a plane that are a given distance from a given point. A circle has 360 degrees, so 1 degree is 1/360th of a circle. A protractor forms half a circle and measures the angles from 0 degrees to 180 degrees. Postulate 7 is the protractor postulate. Consider ray OB, right here, and a point A on one side of ray OB. Every ray of the form OA, so starting back at O, going to that point A, can be paired 1-to-1 with a real number from 0 to 180. Also on page 460, we have the protractor postulate allows you to find the measure of an angle. Consider the diagram below. The measure of angle COD is the absolute value of the difference of the real numbers paired with ray OC and ray OD. That is, if ray OC corresponds with C, so you can see this lowercase c here is representing a number, and ray OD corresponds with D, lowercase d over here, also represents a number, then the measure of angle COD is equal to the absolute value of C minus D. Notice that the protractor postulate and the calculation of an angle measure are very similar to the ruler postulate and the calculation of a segment length. You can classify angles according to their measures. So we have an acute angle, which is between 0 and 90 degrees. We have a right angle, which is exactly 90 degrees. We have an obtuse angle between 90 and 180. And then we have a straight angle, which is 180 degrees, which gives us a straight line. The symbol right here in the diagram above indicates a right angle. So you can see when we have a 90-degree angle, we'll draw this little box shape. Example 2 says, what are the measures of angle LKN, angle JKL, and angle JKN? Classify each angle as acute, right, obtuse, or straight. I've highlighted angle LKN in pink. If we consider the values on the inside of the protractor, we can start with 0 on the right-hand side and follow along until we get to our other ray, KL, which happens to cross right in between 140 and 150. So we would say that's about 145. Since we are starting at 0, we don't really need to write out the absolute value of 145 minus 0 because we know that'll just be 145, but you could. Or you could just state that it's 145 degrees, which is obtuse. And you can kind of see from this image of the highlighted pink angle that it's more than a right angle. Again, this was using the inside numbers on the protractor. Next, we'll take a look at angle JKL. Angle JKL has ray KJ right at 90 and ray KL at either 145 or 35, depending on whether you're reading the inside or outside of the protractor. For angle JKL, it doesn't really matter if you use the inside or the outside numbers. I chose the outside, so I'm going to go with 90 and 35. Technically, we should have absolute values around the 90 and the 35, but since I used my bigger number first, 90 minus 35 is already positive 55, which will give me an acute angle. However, if you chose to use 35 first and subtract 90, you would need the absolute value bars because 35 minus 90 would give you negative 55, and the absolute value of negative 55 is still 55. So either way, you would get 55 degrees. Your angle measures have to be positive, which is why we use the absolute values. For angle JKN, you might be able to tell right away that this is a perfect right angle, but if not, you can use the inside values because the inside values start at 0 and stop at 90. Again, you could write out 90 minus 0 or absolute value of 0 minus 90 and get absolute value of 90 or negative 90, which ends up being 90. But if you start at 0, you can always just pick the number that you end at, which here was 90. So using the inside numbers, we get 90, and that is a right angle. The work for this problem is written out on the next slide. And now I would like you to try homework number 3, 4, and 5 on page 461. Use the diagram below, find the measure of each angle, then classify the angle as acute, right, obtuse, or straight. For number 3, we have angle DAF. For number 4, we have angle BAC. And for number 5, we have angle DAE.